Okay, hello everybody. I'm Paul Albertella. I work at Codethink and I'm the chair of the open source engineering process working group. And if my keyboard finally works, this is what I'm going to go through. So same format as I think the other working groups. We're going to talk about what we did last year, what we're currently focusing on, opportunities for collaboration with other groups and also with other communities and how you can get involved. So the open source engineering process group, our goal or our focus is on developing common processes and frameworks for ELISA, by which we mean processes and frameworks that you can use out in the real world when you're using Linux in a safety context. Within ELISA, we particularly wanted to have a sort of a common framing and vocabulary for the discussions. We've had lots of discussions over the years, and one of the first problems we always encounter is, we're using these words, but do we mean the same thing with these words? So we're hoping to clarify that, but also to develop some specific approaches that we can use and models that we can use when we're thinking about how we're using Linux in a safety context. In particular, because we then want to be able to say, well, we did this investigation in this working group, and we did this investigation in this working group. How can we put those two sets of results together? How can we learn from what we've done in the different working groups and put that together to move things forward? And we also wanted to look at the processes that we actually follow in ELISA as well. So when we're producing material and reviewing it and publishing our results, having some clear processes for that as well, so that we're people know how to participate in other working groups, but also that the results that come from one working group, they can understand them because they understand how they were reviewed and what assumptions went into them. We've historically in OSEP focused on safety analysis, and in particular using STPA, system theoretic process analysis, as a way to get to grips with using Linux in a safety context. And this was focusing on how we can describe the safety use cases and the role that Linux is playing in a system, and using this to derive a set of safety requirements for Linux. Because one of the challenges with Linux is because it is such a deliberately general purpose and adaptable piece of software that's been used in all sorts of different contexts. Making some general arguments about its use in safety can be a huge challenge because there's simply so much ground to cover. But if you can narrow down what role Linux actually has in your safety system, what you need it to do, then you can start to say, okay, what are the requirements on Linux that we actually need to be concerned with. But our discussions in OSEP are frequently much more wide-ranging than that. We talk about all sorts of processes and methodologies. We dive down into technical topics. We kind of look at what the basis for safety claims are. We kind of get into the details of some of the standards and how we can decide whether somebody's actually competent to make a claim or make a contribution. So yeah, if very much welcome contributions from all sorts of people and all sorts of with all sorts of backgrounds. The topics that we mostly focused on and talked about in 2023 were around what I've just described around the safety analysis process. There's been some attempts in other ELISA working groups to use STPA for this, notably in automotive and system architecture working groups. They had some challenges with that. The medical working group's been using STPA very happily and with some really interesting results. So that they haven't encountered these problems. I think one of the things we discussed in OSEP was trying to clarify what the intended purpose of using STPA and what approach you take to applying it. I think we got as far as describing the intended purpose and how we intended it to be used, but we haven't yet picked it up and started applying it again. So I think one of the areas for collaboration in future, which is something we talk about every time this comes up, is reaching out into the medical devices group again and learning from what they did and what benefit they had from using STPA. Coming out of that, we also identify some of the limitations of a top-down analysis approach, which is actually STPA is an example of. If you're framing an argument only at a system level, that means you can tend to disregard or gloss over some of the fundamental technical challenges when you're trying to make an argument in the favor of using Linux and safety. On one of the examples of that, one of my contributors came up with was Linux has lots of memory protection mechanisms and allows you to integrate memory protection mechanisms that are provided at the hardware level as well. But in spite of this, and some of these are very sophisticated and well established, you still have a problem that the kernel itself, because it has a supervisor level role, can theoretically corrupt any process's memory. So dealing with that limitation is one of the important starting points for arguing why you can trust Linux in a particular role. So understanding what these kind of low-level challenges are with Linux and how they can impact top-down argument is equally important, and hence we've kind of moved on to focus on that in the group. So our current topics. The first of these is really looking at some of the background to why we've taken a particular approach to arguing, trying to make safety arguments about Linux, which is you can't rely on what's described as a proven in use argument alone for Linux. And this is something that newcomers to ELISA are often very surprised by, that, why the fact that we have Linux widely trusted in business critical applications, why does that not count for anything in safety? And well, the short answer is it might count for something, but it's not sufficient by itself. And proven in use arguments have a particular meaning in the safety standards. There's a particular set of meanings to the term which aren't always intuitive. But that doesn't mean that there isn't some value in looking at how Linux is used in other contexts and why that might give you additional confidence in how you're using it in a safety critical system. It just means that that's not going to be all of your argument. You do need to say why the way you're using Linux in your safety related system is actually can actually be justified, and why you believe in it. So we have a draft of a paper one of our contributors has been writing, which you can go to our GitHub project and have a look at and comment on, and read that, and we're hoping to get that published soon. The other topic that we've been focusing on and currently focusing on is the idea of coming up with a kind of a concrete list of these technical safety issues that I was referring to. If we can document a set of known limitations and potential weaknesses in the Linux kernel design or the way it's implemented, which we're going to always have to consider as part of a safety analysis, that's really going to help us to get started. But it also means that if I'm using Linux in my system and I want to make sure I've covered all of these, if I have a checklist to go to that's being maintained by a community such as ELISA, and we have Linux experts and people using Linux contributing to it, then that's really going to help us to have that level of confidence that we need, that we're not just covering the set of problems that we've thought of, but actually the larger set of problems that people have identified before and are continuing to contribute to. And I think this is I'm particularly interested in this kind of approach here because it plays to the benefits of having open source communities or open communities like ELISA, is that you're not just benefiting from your narrow set of expertise or the set of expertise that you have on one product or in one domain, but the wider set of experience associated with an open source piece of software and how that can contribute to your analysis. So one of my contributors, Igor Stopper, did a really good presentation on this, which was shared at our recent workshop, and that's available for you to look at. But we're going to be picking up on this in the OSIP meetings and moving this forward, and hope that we can get some more people getting involved in that. Some of the future topics that we're planning to cover this year, beginning with the first one, which is about requirement specification. Matt mentioned the tool Basil, which has recently been added to the ELISA tools group, and talking about what role requirement specifications play in safety and how we can use these to specify what we need Linux to do and how and then show why we're confident it does it. Is a topic that we've been meaning to get to in OSEP for a while. So we have Luigi coming to talk to us this week about Basil. I hope that's going to be the start of a conversation there about not just what the tool is and how we use it, but also how the tool contributes to our confidence about what we're talking about, how it contributes to the process that we use to say why we can trust Linux or the other open source software that we're using alongside the kernel. And then the other topic, which again has been on our list of things to come back to, is about how we review and publish our results, and establishing common processes for those. So the document that we're currently reviewing about proven in use arguments is we're trying to prototype an approach in OSEP for how we review that and how people contribute to it, and when we decide to publish it and what that means. And then we're hoping to use that to start to draw up some guidelines for the other working groups. There has been some work done on this in the automotive working group. So there's a contribution guideline that they wrote up, which is a useful starting point. But we're hoping to I was going to say formalize that, but I think really make it more accessible for everyone, so that we all know what contributing to some material that a working group is planning to publish means, and how we go about doing that. And then some other topics that we're hoping to get onto are about modeling the kinds of safety roles that Linux might have in a system. We came up with a list, which you can see here, of 4 categories, but there may be a much wider range than this. The idea here is that if you're thinking about Linux in a particular role, then that might actually radically change your assumptions for the topic that you're considering. If you're only interested in how Linux might interfere with a safety application rather than considering it to have a role in providing that safety function, then that obviously puts a different emphasis on what you want to consider and how you need to go about looking at it. But this also kind of touches on the work that's been done in the systems working group in putting Linux in the context of a reference system alongside other components, which may have responsibilities for certain aspects of the system where Linux only has responsibility for a smaller set of aspects, and that can really help to narrow down your focus. And relating to that is actually, again, if we're modeling the role Linux has in a system, it's also modeling the behavior of Linux as part of an OS. The kernel isn't all of an OS. We often talk about Linux meaning the kernel or Linux meaning the operating system. They are different things, and it's useful to be clear about which one you mean. But understanding how Linux, the kernel, sits inside a Linux-based operating system is important, and how those different components contribute to the behavior associated with the operating system. And if you have an abstract model of the way Linux operates as part of an operating system and how it interacts with other components, again, that can help you to look at some of these lower level technical challenges, but also to understand it as part of the bigger system that you're considering for your particular safety application. Okay. So, I mean, the opportunities for collaboration, I've already mentioned a couple of internal opportunities for collaboration within ELISA, but we're also very interested in how other open source communities in particular are applying safety and related processes. We had some really interesting presentations from people from Zen and SUSE about their experiences with safety certification and with using ASPICE, which is an automotive process quality model, and they shared those at previous ELISA workshops and seminars. But yes, I think it'd be really interesting to get some perspectives on people in other communities thinking about safety and bringing that into discussions in OSEP. Also, given that we're also thinking about these list of specific challenges with technical challenges with Linux and how we frame those or understand those and collect information about those that other people can use, I would be really interested in contributions from Linux system developers with insight into such challenges. So the challenges that they may have encountered in their own work, or that they're actively interested in contributing to the kernel as ways of dealing with these challenges, and contributing to this idea of a common safety issues list. You can contribute issues, but also you can contribute by reviewing them and helping to improve them in the sense of can people understand what we mean and how they understand how it applies to them, but also documenting known mitigations for these issues as well as just what the problems are. I think we're often as engineers find it difficult to only focus on what's bad about the system. We really want to fix it. We want to work out how we make it better, not just how we document ways in which it's wrong or ways in which it can cause problems. And there's space for both in the safety world. think that's covered the opportunities for collaboration. So if you're going to collaborate, how do you want to do that? As with all the working groups, we have a mailing list. You can subscribe to the mailing list. You can also read all the existing messages there. We've started to share our agendas and minutes of meetings on the mailing list as well, so you can follow along with what we're discussing, even if you aren't able to make it to the weekly meetings. We meet on a Thursday at 2 p.m. UK time. You can find the Zoom details for joining those on the calendar, and get the up-to-date meeting details, because it sometimes can be a challenge working out what time it is if we're in the process of changing between summertime and wintertime. And also, as Philip was saying earlier, we're trying very much to encourage people and shift the focus of our work to collaborating around the GitHub repos, which is where we want to publish the results of our investigations, but also review those results and get input from people who can help us to make them more understandable. And if anybody has any questions, I'll be very happy to answer them.
Thanks, Paul. One thing, I guess, a lot of the work which you've been touched and doing in the OSEP work group are actually items of work which you use in kind of production and practice and Codethink internally, right? So it's really a lot of sharing of the work, right? Or else things.
Yes, that's right. So we've been working on how to construct arguments about using Linux in safety for a number of years now, and in particular, the use of STPA as part of that is something that we've been sharing with ELISA since we started working on it. I was mentioning earlier that we did some work around tool qualification for open source software. That was about qualifying construction tooling and all the tool chain around building Linux and building systems with Linux. So that was yeah, we were happy to share that. But we also have other participants bringing the work from their day job into the group for discussion as well. So yes, I certainly fall back on talking about what I'm doing in the group, but I'm always happy to have other people bring topics to the group to discuss as well.
Okay, thank you so much. And I guess we're perfectly in time for the session about the architecture work group.